Hi, everybody. Welcome to inventory cost portion. So we're going to figure out what is the best way to minimize costs of our business. So let's go ahead and read through this setup. So it is important for retailers to try to control or minimize costs associated with storing inventory and need to reorder more of a product. So those are two big things we're going to do, inventory and reordering. Okay. So let's go ahead and read through a couple of definitions that help us set up our problem. So lot size, the number of units in an order. So how many units per order that we would have. And we usually denote this with X. So this is going to be our X variable, our lot size in this question. So carrying costs or holding costs are costs such storage and insurance that a retailer incurs when large orders of a product are made to try and meet anticipated demand. So carrying costs is defined by this function, h of x, where this is holding cost per unit times our lot size, right? X is our lot size divided by 2. So it says holding cost per unit, but this could be interchangeable with just carrying costs. Okay. In the question, more than not, it says carrying costs, but that is our function for that. Now let's go ahead and look through reordering costs. So reorder costs are such as shipping that a retailer incurs when making an order for a product. So here's a function for reordering costs is the cost per order times the number of items sold during that time period divided by the lot size, which is just X. So cost per order times number of units sold in that time period, typically a year, divided by the lot size X. Okay, and that's also a function that we would need to find. Okay, so then the main question is inventory cost. So inventory cost is a function, right? C of X, where it's just the carrying cost function plus the reordering cost function. So that's the function we need to set up in order to figure out our inventory cost and how to minimize that. So there are a couple assumptions made with these type of questions, right? So one of them is the sales of the product are made at a relatively uniform rate over the time period under consideration. The lot size X of each reorder is the same. That's a big one. And as inventory in stock falls to zero, another order immediately arrives. Okay, so with all this setup, let's go ahead and check out an example. So example two states that a company anticipates selling 3,200 units of its product over the next year. Okay. So each time the company places an order of X units, it is charged a fee of $50. Okay. So carrying costs are $30 per unit, $32 per unit per year. So remember what I said about the holding costs? It's also can be stated as carrying costs. Okay. Now, here's a couple questions. One, how many times should the company reorder each year? Two, what should the lot size of each reorder be to minimize inventory costs? And three, what is the minimum inventory cost? Okay, so in order to get how many times we should reorder each year, we have to find out the lot size first. Use a different color. But we have to figure out this lot size first. And remember, lot size is X. So we got to figure that out first before we figure all these other parts out. So what I'm going to do is label these questions as like one, two for the reorder, and three, lastly, is the minimum cost. So I need to find what the lot size is. So a couple of things first about this question. So since the company anticipates selling 3,200 units, that means it could place any order of size 3,200. So it could be something as if one order of 3,200 units, or it could be 3,200 orders of 1 unit, right? So since it needs to be 3,200, it could be any mix and match like this, right? It could be one order, it could be 3,200 orders, but it has to be 3,200 units. So that means in terms of our lot size, so our lot size will have to be between 1 and 3,200. Okay, so that means X needs to be between 1 and 3,200, our lot size. Okay, just let's keep that in mind, right? It's just a background thought. But let's go ahead and get set up with our inventory cost function. So let's write this out step by step. So step one, create our inventory cost function. Okay, so here we go. So we know that the inventory cost function is H of X plus R of X, right? So what I need to do first is find these guys. So I know that H of X is, just looking at my formulas up here, carrying cost per unit times my lot size divided by 2 and my reorder function is cost per order times number of units divided by, 1 second, let me scoot this over a bit. Let me rewrite this. So our reorder is cost per order times number of units sold over our lot size. Okay. So I know that's what they are. So let me go, we can pick and choose out of our question here. We can plug in some things here. We know our cost, carrying costs, we know our cost per order, we know the number of units. So let's go ahead and write that down. So I know that carrying costs per unit equals right here. Carrying costs are $32 per unit. So that's what that is, $32. Okay. And what's the next thing I need? I need to find cost per order. So cost per order is being charged a flat fee of $50. So that's our cost per order because that's what it's costing us to order this. We're being charged a flat fee of $50 and number of units sold, right? Number of units sold in this year is just this 3,200 units that were restricted in between here, 1 and 3,200 units. So that's just 3,200. So now I have everything I need to fill out these reordering costs and the carrying costs, carrying costs and reordering costs to build our inventory cost function. So H of X our carrying cost is going to be 32 times x divided by 2. And then that just equals 16x because, well, excuse me. Let's go ahead and write this out. So this would be 32x over 2. And that's like saying 32 divided by 2. So this ends up being 16x. So that is our carrying costs. And now let's check out our reordering. So this is cost per order is $50. So 50 times number of units, that's 3,200 over X. And this is 50 times 3,200 is 160,000 over X. Okay, so our reordering is 160,000 over X. So what this means for our inventory costs, is just the sum of these two functions, right? So let's go ahead and write that out. So, excuse me, have to make another page here, running out of room. But our inventory cost is going to be 16x plus 160,000 over X. Okay, and remember, we are restricted between 1 and 3,200 units. Okay, so with 1 between, or X between 1 and 3,200. Okay, so that is our inventory cost function. So what is the main, I need to find the lot size to minimize inventory costs. So when we see that word minimize or even maximize, that means I need to find a critical value. It relates to the derivative. I need to find this critical value that's going to minimize it. So what I need to do is find the critical value of this here, find the lot size that's going to minimize it. So I need to find the derivative of this. So step 2, what I'll write here is find critical value of this inventory cost function. Okay, so I have C of X equals 16X plus 160,000 over X. I need to find the derivative of that. So in order to do that, I need to rewrite this a bit. I need to rewrite this. I need to bring this X up, make it X to the -1 so I can apply the power rule derivative to it. So let's go ahead and do that. I'll say rewrite C of X as 16X plus 160,000 X to the -1. Okay, so now, right, we got to find the derivative. So the derivative of this is C prime of X equals, the X just goes away, 16, and then this becomes plus 160,000 times -1, because the -1 drops down, X to the -1 minus 1, so -2. Okay, so this ends up being 16 minus 160,000, X to the -2, and then I want to rewrite this by bringing this guy back down. So when I bring it back down, it will make it a positive X squared. So this will be 16 minus 160,000 over X squared. And that's my derivative. Okay, so the next thing we got to do is set this equal to 0 to find the critical point that will minimize our inventory cost. So setting this equal to 0, I will get 0 equals 16 minus 160,000 over x squared. So I'm going to add 160,000 over x squared to both sides. Okay, so this will cancel out. And so what I end up with is 160,000 over x squared equals 16. Okay, remember, I'm trying to get x by itself. Okay, so I need to get it out of this bottom here. So what I'm going to do now is multiply x squared to both sides. So this will cancel that out. And so what I'm left with is 160,000 equals 16x squared. Okay, still trying to get x squared, x by itself. So I'm going to divide by 16 now. So divide that. And what I'm left with is x squared equals 160,000 divided by 16 is going to be 10,000. Okay, so I still need to get this x squared by itself. Last thing I will do is take the square root of both sides. So what I end up with is x equals plus or minus 100. So I get x equals 100 and x equals negative 100. Okay, so what does our lot size need to be in between though, right? We found some numbers for our lot size that will minimize cost, but what does our lot size need to be between? Our lot size needs to be between 1 and 3,200. And as we see here, this is a negative 100. That is not between 1 and 3,200, right? So what we can do is just disregard this negative 100. Okay. And also, if you think about this in a business sense, it doesn't make sense to have a negative 100 lot size, right? You wouldn't be able to apply that. So we can disregard this negative 100, and 100 is our lot size that we need to minimize inventory cost. So one thing to know here as well is that back up here, that x equals 0 would make this undefined, making it also a critical point because we would have like 160,000 over 0, right? But really the same rules apply in that we need to be between 1 and 3,200, and 0 is less than 1, which is not in between 1 and 3,200. So we can also disregard that as well. Okay, so 100 is our lot size that will minimize inventory cost. Okay. So let's go ahead and say that. So, excuse me, different color. So x equals 100 is our desired lot size. Okay, so that answers that first question, right? What should the lot size be to minimize inventory costs? And we found that to be 100. Okay, so that's the first part of this question. Okay, so going to add another page. This is quite a long problem, but the next part is, right, to figure out how many times should the company reorder each year. So what I'll do here is say step 3, number of orders. Okay. So to minimize inventory costs, the company should place, and what we're going to do is cut up that 3,200, right? I'm going to cut up this 3,200 by the 100 lot size we found in order to find how many times we should reorder. So if we look at this here, number of units sold divided by lot size, that's really what we would need to check out in order to find out how much we should reorder to minimize that cost. So I'm going to divide number of units, which is 3,200, divided by the lot size we just found. So let's go ahead and write that out. To minimize inventory costs, the company should place 3,200 over 100 equals 32 orders. Okay, so that means 32 orders of lot size 100. And that's pretty much it. So we're cutting up 3,200 into 100s, which is 32 orders. Okay, so that's it for that second question. So a little bit less work this time, just using a little bit of knowledge of reordering. So now the last question is coming back up here. What is the minimum inventory cost? So to get the minimum inventory cost, what we're going to do now, right, kind of that works with minimums and maximum. We're going to take this critical value 100, our lot size, and plug it back into the original inventory cost to get that minimum inventory cost value, dollar value. So we'll say step 4, minimum inventory costs. Okay, so I'm going to take 100, plug in x equals 100 into that inventory cost function. So my inventory cost function is 16x plus 160,000 over x. So we'll have C of 100, plugging in 100. So 16 times 100 plus 160,000 over 100. And I end up with 1,600 plus 1,600, which is 3,200. Okay, so what does this mean? So what this means is the company, forgot a dollar sign here. Sorry. So that's the minimum inventory cost. Okay, so what is the final answer putting all of this together, right? So really, final answer is the company should reorder 32 times each year with a lot size of 100 to have a minimum inventory cost of $3,200. Okay, and so that is how you would do a inventory cost function question given all of these parameters and using all of these formulas. Okay, so in the next video, we're going to see a way to do it a little easier with a formula, but that's it for this video, and I'll see you next time using the formula. Okay, thank you. Bye.